trinomial. All right, now let's go on to the next idea, which is completing the square. Shocking. Okay, so this technique is called completing the square. Now the algebra is going to look really confusing, but it makes sense if you look back at our example or examples. Here's how it works. X squared plus bx, that's your original binomial. What we're going to do is we're going to write that as quantity x plus b divided by 2 squared minus quantity b divided by 2 squared. Whoa. Could we have done that right from the beginning? This is just b divided by 2? It is. So that perfect square trinomial, when you write it as quantity a plus b squared, it's just the x, and then it's just the b divided by 2 quantity squared, minus that b divided by 2 squared. Okay, how about this? Solve x squared, wait, solve. Solve means finding all the values for the variable that make the equation true by using completing the square technique. Okay. We have learned how to solve this before. We talked about if you have an x squared and an x, we usually use the ZPP or the zero product property to solve this. But this time, here's what we're going to do. Let's make a plan. We're going to write this as ax squared plus bx plus c equals 0. So that means I'm going to add 15 to both sides. Now we can talk about both sides because it's an equation. So x squared plus 16x plus 15 equals 0. Okay, we could use the zero product property and solve that, sure. But we're going to try this completing the square technique and see how it works. So according to the algebra, and I'm just going to follow it really specifically, x squared plus bx. Let's say that this is x squared plus bx, okay? Let's say that this is x squared plus bx. There it is, right? Right now, the plus 15, is this a perfect square? And the answer is no, because this is a perfect square, but 15 is not a perfect square. So let's just look at what's in the green box. And what we're going to do is we're going to rewrite that as x plus b divided by 2 quantity squared. So we're going to rewrite this as x plus, well, b was 16, divided by 2 is 8 quantity squared. There's the x plus b divided by 2 quantity squared. Then we're going to subtract, okay, subtract b divided by 2 squared. Here's b, 16 divided by 2 is 8, squared is 64, minus 64. That is just the green box. What I've done is just simply rewritten what's in the green box like this using the completing the square algebra that's to the left. I used this algebra to rewrite this green thing to this green thing. You see the plus 15 equals 0? That's still there. It has not gone anywhere. Okay? All right. Now we can simplify this, the left side of this equation, this expression, algebraic expression. Quantity x plus 8 squared. Negative 64 plus 15 is negative 49 equals 0. Hey, wait a second. I could add 49 to both sides. And then I get quantity x plus 8 squared equals 49. Now, using the technique we learned in the last section, I can square root both sides. When I do that, I must take the positive and the negative roots. And I'm going to create myself a little space in this next box down here. So this is going to create two equations. X plus 8 equals 7. And x plus 8 equals negative 7. All right. Now, subtract 8 from both sides. Using the subtraction property of equality, I get x equals negative 1. I subtract 8 from both sides. Using the subtraction property of equality, I get x equals negative 15. All right. Well, we solved, because we're finding the values of the variable that make the equation true. Let's make sure that does. If I substitute negative 1 in for x, negative 1 squared is 1 plus negative 16. 1 plus negative 16 is negative 15. Yep, works. X equals negative 15. Quantity negative 15 squared, what is that, 225 plus 16 times negative 15. Let's find out. We're going to use the calculator here, which is slowly loading. 225, and then we're going to, it's going to end up subtracting, right? Subtracting whatever 16 times 15 is. And unfortunately, I don't think I have parentheses on here, so I might have to do this like this. 16 times 15, order of operations, after all, is 240. So I do 225 minus 240, and boom, negative 15, it all worked out. So I did indeed find the correct solutions. Now I feel confident enough to box these and say that these are correct. These are the values of the variable to make the equation true. Okay, a couple reflection points. Did I need to add 15 to both sides to begin with? No, I didn't. The fact is, the algebra for completing the square is only based on the x squared plus bx. So I no longer need to write this as ax squared plus bx plus c equals 0. I can leave this 15 on the right side. That's nice. So I could have just only worked with the x squared plus 16x. In fact, why don't we do that on this one? Why don't we do that on this one? So first thing, though, on this is a little bit different. See how we want x squared plus bx? Do we have x squared plus bx? No, because we got a 2 out in front. Remember how I said that we want to make sure we make 1 the coefficient in front of x squared. So let's first factor out the 2. So now you should be getting a little order of steps in your head. First, factor out the GCF if you're solving an equation with x squared and x. Okay, now I divide both sides by 2. Could I divide both sides of this equation by 2? Yep, division property of equality. And now I'm left with x squared plus 10x minus 4 equals 0. Okay, just like we were talking about before, I only need x squared plus bx, right? I only need x squared plus 10x. First, I should actually check, is this a perfect square trinomial? It could be, right? It actually could be, because 4 is a perfect square, but it's plus minus, and that's not any of our special product forms, right? Because quantity a plus b squared is a squared plus 2ab plus b squared, and quantity a minus b squared is a squared minus 2ab plus b squared. So this is not one of our special product forms. So I'm going to add 4 to both sides, and then I have x squared plus 10x equals 4. Okay, I could have used zero product property here. I could have to solve it, but this is a different technique, and zero product property won't always work. Okay, x squared plus bx. How do we do this? Well, that puts us in this situation, right? This right here can now be rewritten using the completing the square method. And the way we do it is we take the x, we add b divided by 2. What's 10 divided by 2? That's 5 squared minus b divided by 2 quantity squared. 10 divided by 2 is 5, squared is 25, equals 4. Okay, now I'm just going to rewrite that up here so there's no confusion. I don't want to accidentally skip any steps that confuse you. Okay, minus 25 equals 4. Okay, now I'm going to add 25 to both sides. And I get quantity x plus 5 squared equals 29. Now I'm going to square root both sides. And when you square root both sides, how many equations do you need to write? 2. So x plus 5 equals the positive root of 29. I don't know what just happened to my square root. I forgot to write it. Positive square root of 29. And x plus 5 equals the negative square root of 29. Okay, I subtract 5. Well, I suppose I could look for, are there any perfect square factors of 29? I hope you know 29 is prime, so there are none. So this is going to be x equals the square root of 29, whatever that value is. I should say positive square root of 29. minus 5. And x equals negative square root of 29 minus 5. A lot of times, books or you'll see just written, they'll have both solutions together. They'll have positive or negative square root of 29 minus 5. And you could approximate this. Remember, the square root of a non-perfect square is an irrational number. And so you could approximate that somewhere between 5 and 6 minus 5. So it's going to be really close to 0 are going to be the values that actually make this equation true. And, you know, I won't go over all of that. It's going to not be totally 0, but those are our two solutions. Not an easy section, pretty hard. I would say the summary, even though we don't have a lot of time, the summary is that in order to convert a binomial into a perfect square trinomial, you want to have it in x squared plus bx form. And then you follow this algebra where you take b divided by 2. So you create the x plus b divided by 2 quantity squared minus that b divided by 2 quantity squared. All right, guys, lots of information in that. Please email me or go on Google Classroom and ask any questions you have there. You're all an amazing group of people, and watch this video 100 times if you need to. Keep it up. Bye-bye.